by Center for Agriculture Market Intelligence, NAHEBcast, in collaboration with College of Agriculture Information Technology, Anand Agricultural University, Anand. For today's technical session, we have with us Dr. Amol Dev Vibhote, who will be delivered lecture on the topic named Remote Sensing for Soil Analysis and Mapping. Dr. Amol, sir, in his brief introduction, he is currently working as an assistant professor, School of Computer Science, MIT World Peace University. He has more than 6.5 years of academic experience in research, innovation, and teaching at the PG level. He has published 5 Indian patents and authored and co-authored over 55 referred journals, books, chapters, and conference papers in reputed international journals and conferences indexed by Scopus, SEIE, and UGC. His specialization area is hyperspectral remote sensing, GIS, and remote sensing of soil, crop, urban areas, etc. His research interests include geospatial technology, digital image processing, pattern recognition, big data analysis, Internet of Things, machine learning, and artificial intelligence. He has received BSR fellowship under SAP by the University of Grants Commission, New Delhi in August 2013. He has been awarded best paper and session chair in the international conference and second prize under the concept paper competition. He has delivered lectures as a resource person in state level seminar and training program. It's a very privilege to have you, sir, with us. I welcome you, sir, on the behalf of Anand Agriculture University for today's technical session. Over to you, sir. Thank you.
Thank you so much, Shraddha madam and sir and all audience. Thank you so much for nice introduction. Shall I directly start my technical session?
Yes, sir. Yes, sir. You can begin.
Thank you so much. So my topic is remote sensing for soil analysis and its mapping. Basically, remote sensing is one of the recent technology. So through which we can capture multiple images and even we can capture the earth surface features for different purposes. So here our application is soil analysis and mapping through the remote sensing. So basically, remote sensing is one of the part of geospatial technology. The geospatial technology deals with remote sensing, GIS, and GPS. So the combination of these three technology is basically known as geospatial technology. Here, for this presentation, I have made some slides. So these are some contents I will going to cover in the presentation. So firstly, I will see the background, then advancement of the technology, then what is the exact problem in soil analysis, what is the need of remote sensing in soil analysis, and then some case studies with satellite data sets. So what is the use of soil study using remote sensing or geospatial technology? As we know, soil is one of the most important resources and vital component of the ecosystem. It has different application. It filters the water, provides the nutrients to the vegetations, as well as different crops and plants, which supplies us food, energy, fiber to maintain the health and habitation. So, but there is extraordinary pressure on soil due to urbanization, industrialization, and degradation. So that is why it is necessary to preserve the soil for future enhancements and future betterment. So here we can see this life cycle of soil. It is given in these figures. So for that purpose, soil mapping is important because we have to preserve the soil for future applications for food production, digital assessment of various soil properties, and its classification along with mapping is important for different applications. But soil structure is heterogeneous and dynamic, so it is a really challenging task to preserve the soil. Here, our technology is good, and we can preserve that, and we can use our soil for better food production. Recently, a remote sensing technology is available. It is giving the images in the form of multispectral datasets, hyperspectral datasets, or panchromatic datasets. As per hyperspectral and multispectral dataset, there is a difference between hyperspectral and multispectral data. In hyperspectral dataset, we are having number of bands, and we can identify the minute details of any type of feature. So through the hyperspectral remote sensing, we can identify the content of soil and its properties as well. Even with the multispectral data as well, we can do, but multispectral data is having limitation. Only limited bands are there. Even the bandwidth between two bands are also more. In hyperspectral data, we can have good bandwidth. Number of bands are there, so we can identify number of features through the hyperspectral remote sensing. Okay, so soil analysis with hyperspectral remote sensing data. We are having hyperspectral remote sensing data in the form of digital images or in the form of spectral signatures. So basically, we have used in our research both the data sets like images as well as spectral signatures of soil. So for that purpose, we have collected number of soil samples, live soil samples, and then we have taken the spectra of that soil sample. So hyperspectral remote sensing for soil analysis will be a constructive tool for agricultural and food production. So here one definition is given, the grouping of soil with properties into units which are georeference and map are known as the soil mapping and soil classification. The background of the study is that why to use geospatial technology, because as we know laboratory methods are very time consuming. Even they require number of chemical components, they are expensive, more labors are required. Here in this left diagram you can see some scientists are there who are just identifying the content from the soil through the chemical techniques and all. So laboratory methods are time consuming as well as they require more labors as well as it is based on chemical. Okay, and one more important thing is that why not to use the laboratory method, because it not this technology or traditional methods do not provide the spatial and temporal inconsistency. Okay, so with the help of remote sensing technology, we can capture number of features from the soil and we can cover much more area. Okay, and even as per the time series, we can collect the data, we can analyze the data, and we can give the better decision based on that particular data. So there is a universal need to develop a speedy and less expensive method. Conventional methods have been carried out through some topographs and even some maps as a reference. But again, it has also time consuming, tedious, and subjective. So in this case, hyperspectral remote sensing is providing good spectroscopy in the range of VNIRI, that is visual and near infrared. So range is based on 350 nanometer to 2500 nanometer. So it has a lot of advantages like this technology is productive, rapid, non-wasting, non-distinct, and non-destructive, and more accurate as compared to our conventional methods. Okay, the in situ method provides information about the soil attributes without any compounds. Even single spectra of a particular soil can be used for analysis the different contents from the soil. So even the customary methods of remote sensing image classification are based on special spectral features, and in our proposed methodology, we have given this type of scenario and used for identifying features and mapping the soil classes. So here you can see this right figure, hyperspectral image or hyperspectral data cube is given, and which is showing the number of features. Even the details has been also given here. Green vegetation, then soil, and then other features have been given here. So basically, with the help of this type of technology, we can do a lot of things. So that is why it is important to use the geospatial technology along with hyperspectral data. So here, one more important point I want to highlight that United States of Department of Agriculture has been set one criteria for soil analysis. So they have given some keys for soil taxonomy and soil structural soil classification. Even World Reference Base is also given some criteria for soil analysis, and they have mentioned that some international standards for classification of soil. So in our study, we have used such type of standard criteria, and we have analyzed the soil and mapped it according to the soil properties. This is the general proposed experimental work and soil analysis techniques. So, see in this diagram, this is the general schema which several studies are carried out through these data sets and with this type of methods. Generally, we can have field data and spectral measurement according to the field data, and then remote sensing data, which is pre-processed. Either it may be multispectral or hyperspectral. So spectral reflectance of images will be carried out, and then spectral feature extraction will be also carried out, and accordingly classification will be done. And lastly, the accuracy will be tested. So everyone is following such type of criteria. But in our case, we have proposed the methodology. In this case, we have just taken the images of hyperspectral data as well as multispectral data, then ground truth data, laboratory data, and then spectral measurement data. So signature of soils we have carried out. For that purpose, we have gone through field campaign and some samples like 34 soil samples we have collected from our particular region. And these soil samples also tested in laboratory for identifying the soil properties for validating our proposed approach. Even spectral measurement of those collected soil samples were also carried out. So here in the spectral measurement, we have done some important pre-processing steps, and those are nothing but the removal of the fringe spectra, then spectral pre-treatment like a smoothing of that particular spectra we have done, then transformation of spectral signature we have done, and based on the pre-processed data, we have done the correlation study based on the laboratory methods. So whatever samples we are having in the laboratory, all those samples we have tested through the traditional methods. A number of limited samples we have tested with the laboratory methods, and according to the result obtained through the laboratory methods, we have correlated the study, and we have checked whether the acquired spectra by our device and the laboratory methods are matching or are they correlated to each other. Those study we have done, and based on the correlation study, we have detected the sensitive bands with respect to the particular soil properties. And after it, we have performed the some modeling with machine learning modeling, that is PLSR modeling, partial least square reference. So this modeling we have done, and according to the modeling, we have just given the properties and developed our own spectral signatures of soil. So this is our main contribution while carrying out this type of study. We have developed the spectral reference of particular soil, and accordingly accuracy was also assessed. So here one case study for non-imaging data sets we have done with respect to the samples. Similarly, while ground truth, we have collected number of points, and those points we have used for giving the training to the satellite data. Here, two satellites data sets have been used. Multispectral, that is the Indian remote sensing P6 satellite, that is the ResourceSat second, LISPO data. Some image processing, pre-processing has also been done on this multispectral data, and even in hyperspectral data set also we have taken, and that data is also pre-processed with some advanced methods. Multispectral data, as I mentioned, that is having some limitation, but the important thing is that here multispectral data was giving us good spatial resolution, but in case of hyperspectral resolution, the hyperspectral data was giving the good spectral resolution. So spectral resolution of hyperspectral data is good as compared to the multispectral data, but multispectral data is giving good spatial resolution means whatever pixel we are capturing through the satellite images or satellite sensor. So pixels are good in multispectral data, but in case of hyperspectral data, pixels are huge, means 30 by 30 meter area is covered in a one single pixel. Here, in case of multispectral data, some meters like 5 to 6 meter area is covered in a multispectral data. So spatial resolution means geospatial resolution is more in multispectral data, but in hyperspectral data, spectral resolution is more. Means in a particular, for example, this is my hyperspectral cube. and this is XY coordinate, for example, XY, and these are the some spectral bands. Let's consider here in case of multispectral data, we have limited spectral bands. Band 1, 2, 3, like red, green band, yellow band, then VNR band, like that. Some bands are there, but the distance between two bands are more in multispectral data. But in case of hyperspectral data, there is a minute distance. So all these bands are connected to each other. So we can acquire the good content from the data. So here spectral properties we can have the we can have the continuous spectra through the hyperspectral. But here in case of multispectral data, this may be the gap we will get in this case. Okay, so differences are more in two bands, so that is why we cannot use for spectral classification. But in case of hyperspectral data, it is useful for identifying the minute detail. For example, in the band of green and near infrared, for example, some features are there. So if these bands are connected, we can identify the minute details. But in case of multispectral data, see the difference between these two bands. If here is having, for example, some features, so we cannot identify because the distance between bands are more. But for spatial resolution, we have used this data. Then some pre-processing has been done, and then spectral reflectance standard false color composite image has been generated, and spectral spatial feature extraction methods were performed on that data. So while defining the ground truth, while giving the training, we have used a number of features. Ground truth points, we have used even laboratory analyzed soil properties data. Also, we have used developed ground reference spectra or signature of soils were also used, and these all features we have combined with a single training set, and then we have given the training to the satellite data. And here we have used three different classification methods based on some statistical and non-parametric methods. SUM is one of the methods we have used, the maximum likelihood and spectral angle mapper. So these three classification methods we have used for classifying the soils. So see here, end members means the pure spectra of particular object. In our case, the pure spectra of soil was generated through these laboratory methods. We are having one ASD field spectrometer device. So through that we have collected the spectra and we have generated the standard spectral library of particular soil. So that standard spectral library is nothing but the end member, means pure spectra of particular object. So object was soil. That object we have used in the training of satellite data. So we got good accuracy in that case. Even some of the points we have used for validation as well as testing our results. In case of hyperspectral data, so this data is in the form of raw data. So firstly, we have to convert the raw data into the suitable format. So here we have generated and downloaded the data and converted into the HDF format, which is the standard format to analyze the hyperspectral data. Then again here as well, we have carried out some image processing, pre-processing methods. So bad bands, whatever bands, number of bands in case of hyperspectral data were 242. So all these bands were not suitable for any type of study. Okay, so our motive was to analyze the soil, but we cannot use all these bands for any type of application. Some of the bands are having information and some of the bands are not having. So in that case, whatever bad bands are there, or those bands which are not giving any type of information, which were eliminated from the data sets. Even some particular bands are having some spectral straight lines. So that straight lines were also removed, and the digital number data we are converted into the radiance format. Okay, so see this image pre-processing we have done. So it is important to remove this type of bands and the columns. Even it is necessary to convert the digital number, because Downloaded data is available in the form of digital numbers. So we have to convert the data into the form of radians, and according to the radians value, we can use some atmospheric correction methods and we will get the reflectance method. So whatever earth surface features we are having, those earth surface feature reflectance of those features will be used here. So in that case, renovated radiance data is converted in the form of reflectance data. Reflectance we have used through the atmospheric correction. So as we know, in our environment, number of gases are there, number of different environmental parameters are there. So in that case, it is necessary to use or remove the atmospheric parameters through the data. Okay, even cloud is also there. So those clouds and number of parameters we have removed through the atmospheric correction methods. Here in our case, QAC is important method we have used. And afterwards, spectral reflectance image was generated and used for further processing. So spatial subset was done, means particular area were cropped because satellite image has huge size. So in that case, we have focused on particular area. So that is why spatial subset has been generated, and based on that particular area, we have applied the machine learning algorithms as here we have mentioned SVM, maximum likelihood, spectral angle mapper. Even a dimensionality of the data is also reduced through the PCA method. Even minimum noise fraction method is also used to reduce the dimensionality, because I mentioned here 242 bands were there, some of the bands were removed. Even after removing bad bands and bad columns, we got 140, 155 bands. Okay, so this data is also having number of bands. So it is necessary to reduce the dimensionality, because if dimensionality is more, in that case we cannot achieve the good accuracy. That is one of the reason to reduce the dimensionality. Here in this case as well, we have removed the dimensionality and then we have extracted the soil features. So for that purpose, we have used some spectral indices methods, like soil indices we have used. I will show you what are the methods which are used. Those soil indices were also used in the spectral feature extraction of soils, and then classification will perform. So according to the classification methods, we got some results, and the results we have confirmed with the ground truth methods, ground truth points, even other features, and we have generated the final spatial maps of some soil types. So this is the proposed methodology which we have followed. In generally, people are using like some data, either multispectral or hyperspectral feature extraction and directly classification. But this type of scenario or this type of methodology they have not performed. So we have performed this methodology. So this was our study area, which falls under the Aurangabad region with such type of latitude and longitude, which are having this much of size. So limited area we have chosen because we want to test our algorithm. So for that purpose, we have taken only this part of hyperspectral data as well as multispectral data. Here you can see this is the hyperspectral data, and even with this is the multispectral data. Even with this multispectral data, we cannot identify which is the exact feature. So if you are having good knowledge of remote sensing data, in that case you can just generally you can say this red color is showing for example crops, this type of cyan color is showing vegetation area, or we can say hilly areas. Here we can see water body area. Even here also hilly area is there. So there is one river. Here some cities are there. So if we are having false color, standard false color composite of image, satellite image, and if we are having good knowledge of image, so in that case we can generally identify what are the features. So generally we can classify these are some crops or vegetations, some of these agricultural area, some of the hilly area, a river and water area, but we cannot identify the minute detail. So for that purpose we'll require the hyperspectral data. So Elevation of the studied area was this one. I think this is not necessary here because our focus is different. So I'm skipping this. Yeah. So here three different type of data sets we have used. First of all, hyperspectral data. So EO1 Hyperion is one of the satellite of NASA. So they have given the hyperspectral data. I think right now this mission is destroyed by the NASA. But some of the images are available up to 2017. We can download it for research purposes. So this hyperspectral data, which was freely downloaded by the NASA website, USGS is one of the source which provides the data, hyperspectral data, and ASD spectral radiometer. This is the spectral radiometer device we have used to acquire the spectral signature of particular soil sample. Okay, so this device is having much more cost, and in our lab this device is available. So that is why we have just used this device as well for acquiring the spectra, because we got the pure spectra, pure signature of that particular soil sample we have got, and that pure sample we have used for classification of satellite image. So this combination we have done. So that is why it is important to use the proximal sensing data. Either it may be some device data, or maybe ground truth data, or maybe some maps, even Google Earth Engine also we can use. So different type of data sets we can use as a proximal sensing for validating our results. Third data sets we have used, that is a LISPO data, which is multispectral, as I mentioned earlier, and even GPS points also we have collected through the ground truth and survey of India topo sheet. At this scale we have seen even field data as well. We have seen some of the pictures we have captured. We have visited number of things. We have visited to farmers as well. We have noted that what was the exact feature there, what was the crop pattern. So according to crop pattern as well, the soil is changing. So that all type of scenario has been mentioned and used in the study. Even to perform such type of study, we have used the number of tools and software. So NV is one of the best tool for hyperspectral remote sensing. So basically, every researchers who is working on hyperspectral data. So this type of software we can use for it because it is giving good functionality. So a number of features are there, number of functions are there, we can use it. Even ArcGIS is used to develop the final maps. RS version is used for capturing the spectral signatures of soil samples. R software is also used to develop the model. SPS is also used for some cases to do the correlation study. Even Unscrambler is one of the software is used for developing such type of models. PLSR model was developed. Even some pre-processing of non-imaging data. So spectrally signature data we have done in Unscrambler, and Python is also used. So number of tools, softwares we have used for number of data sets. So here is the general features of hyperspectral data sets have been given. Hyperspectral data was acquired on this date, 15th April 2015. And as I mentioned, USGS is providing the data, and the range of the data is VNR, visual near infrared, from 400 to 1000 nanometer, and for shortwave infrared data 900 to 2500 nanometer, which is the from the push broom mode. So it is one of the important mode. So that mode has been given by the satellite, and through that mode we have acquired our data. So spectral bands were to 4 to, as I mentioned, 1 to 70 bands were for VNRI, and remaining bands were for shortwave infrared. So radiometric calibration parameters we have performed, and 198 bands were acquired. But after 198 bands as well, some bad bands were there. That bands were removed. So these are the some parameters of hyperspectral Hyperion data. Prototype was orthorectified by the provider, which was available in the form of GeoTIFF level 1T format. We have downloaded. Even there are three other formats are there. As per our requirement, we can take anything. If you want to perform the atmospheric correction method. So, or if you want to work with the raw data, we can use the level 0. Our motto was to analyze the soil, so that is why we have used the level 1T data sets, and the data acquisition date was 20 March 2015, because at the same time we have collected the soil samples when the satellite overpass was there. Orbit path, target row path, as well as some spectral resolution and range is given here. So spectral range means distance between two bands were only 10 nanometer. But in case of multispectral, it is more than 20, 30, 40 nanometer or even 100 nanometer. And the spectral range was 350 nanometer to 2500 nanometer. Spatial resolution in case of hyperspectral data is 30 meter, but in case of multispectral, it was good. So number of bands were 242, and swath was this one. Data format was available in the form of band sequential, and even see here 0 to 9% cloud cover was there. So it is necessary to pre-process the this type of data, and spectral coverage was continuous. So that is why we were able to acquire the minute detail of soils. And temporal resolution means for every 200 days, the same satellite will overpass the same area. So that resolution we have used. And soil samples 0 to 20 centimeter depth topsoil we have collected in between these dates. Even this date, soil sampling date, and satellite overpass date was similar to each other. So we matched our data, we matched the features from the real-time data as well as from the ground truth data and satellite data. So climate was clear when we performing the soil sampling. The samples, the cotton, wheat, jawar crops were harvested while sampling the soils, and the surface croplands relices were removed by the hands, and the airtight containers like some plastic bags we have used for that collecting the soils, and all those soils were airtight, then passed through the MMCU, and then some samples, totally 74 samples were collected within this particular area, right? And from the 74 samples, 15 samples were sent for the laboratory purpose. In the laboratory as well, we have just perform the chemical methods and perform the particular study, and remaining 59 samples were used for acquiring the features like spectral features and then satellite processing. So the soil was deep and medium black, even cottage sandy loam texture was there, and calibration for training 15 and for validation 59 samples were used. Hyperspectral measurement of the spectra, whatever spectra we have collected. So through this device, we have generated the spectra. So particular range of this device has been given here. Even the wavelength is also similar with the satellite data, but uniquely we have taken the number of features, number of spectral values per spectrum. Here the spectral resolution is again high. 3 nanometer is the spectral resolution for this device. So fewer spectra we have generated, and in case of hyperspectral, the resolution was 10 nanometer. So there was a little bit a difference between non-imaging and imaging data. So some sampling was done for acquiring the spectra. We have used petri dish with this 20 centimeter diameter and 2 centimeter thickness. So illumination source was used, that is the 75 watt tungsten parts halogen film to highlight the samples, and then some angles for 60-degree of zenith angle of at the distance of 45 centimeter from the soil sample, and that device we have used, and the fiber optic cable with 8-degree was also used because it was giving the good spectra. Even wide spectrum is also used to optimize and calibrate the data, and average of 10 spectra for each sample we have calculated. Means for each sample 10 times we have scanned that particular sample, and then average of 10 spectra we have finalized with the pure spectra. This software, as I mentioned, is used to record the spectra. So this device is available in our lab. So that was used to scan it and to generate the spectra. Multispectral data. Here the information of data is given. Spatial resolution is 5.8 meter, so which is high. Satellite name was resource at second. Sensor is a linear imaging cell scanner. Fourth version. Number of bands were only 3. See here the difference between hyperspectral and multispectral. In case of hyperspectral, there were 242 bands, and here only 3 bands: green, red, and NIR. But spatial resolution is good, so that is why we have used it. Even swath is 23.5 kilometer, and radiometric resolution is also good for multispectral data, that is 10 bits. So these 3 data sets we have used. Now, what actually we have done? So this is the first part of our case study. So there we have used non-imaging data, and we have performed some of the soil samples and analyzed the remaining data sets. So MIT soil and water testing laboratory we have used for performing the laboratory methods, and only 15 samples were tested in the laboratory, and remaining samples were given to the particular device, and those samples were scanned, and some pre-processing, as I mentioned before, were done, and acquired the spectra. So .asd file was generated by that particular device, spectral radiometer device, and that ASD file we have converted into the form of ASCII values. So afterwards we have given some numbers, perform some pre-processing methods. So first derivative transformation, and then Savage-Golay method we have used for smoothing and getting the good spectra. So here is the formula we have used for Savage-Golay. So, and some mathematical treatment also we have given for Savage-Golay method. So 2 was the order of polynomial. So this is one of the method where we can give the number. So as per our requirement. So in case of our study, we have given the 2 as a polynomial order. First order derivative was used, and then first smoothing point was taken, and then second smoothing point was taken by the second and fifth with respect to that particular data. And derivative transformation method is used to eliminate the partial effect, size effect, and noise. So noise we have removed from the spectrum, because every device is generating such type of noise or some little bit noise whenever we capture any type of feature or any type of spectra or image. So in that case, it is necessary to remove that noise and effect, which is caused by either environment or light or other parameters of sensor. In that case, we have done this pre-processing and remove the noise as well as smoothed the spectra. Then statistical modeling was done, as I mentioned. Correlation study we have performed. So correlation with the lab method data results and our results we have combined and generated one partially square regression based modeling for spectral extraction of soil. So for modeling purpose, we have used the PLSR method, partially square regression method, and some input value have been given to the method, and we got the particular model. So U1 cross out validation method was used to check the model, and it was used to calibrate the spectral data with reference to the laboratory data. Okay, so these 2 methods we have used, and we have developed a particular model. So that model were tested different times, and prediction accuracy of that particular developed model is also evaluated by some method. So coefficient of determination, we can say R square values we have generated. RMSCP, root means error square of prediction, is also generated, and RPD value were also generated. So here some formulas have been given. All those formulas were used for finding out the accuracy and evaluating the results. Now, in the second case study, as I mentioned in the proposed methodology, satellite data sets were used. So hyperspectral data, remove the bands, number of bands, and then see here, you can see some of the bands like 8 to 57 bands were calibrated. And in case of shortwave data, 77 to 242, 244 bands were 224 bands were calibrated, and remaining bands were not calibrated. So 1 to 7, 58 to 70, 71 to 76, and 250 to 242. So these bands were not useful. Only these bands were useful, which were used, and remaining bands were removed from the processing because these bands were not giving any type of information. Means zero bands were there. So those bands were removed. Even some signal or noise bands were also there, or overlapped bands were also there in that data. So 56 and 7, 57, 77 and 78 bands were there. Again, these bands were also removed. Now, one more important part is here. Water vapor bands are also there in the hyperspectral data, even in the non-imaging data. In that case, some of the bands like 120 to 130, 132, 165 to 182, 185 to 87, and other bands. So these bands were also identified. So identification of these bands are important because at this range, our spectra will be delimited. Means the reflectance were low at that particular band. Let's consider this is our image, or this XYZ coordinate, and this is our, let's consider this our spectra of a soil. So at this band, as we know, bands were started from 350 range to 250 nanometer range. So this was the particular range. At some range, water vapor bands are there. Means, for example, here is the water vapor bands. So at this stage, we can see the reflectance is low. But in case of other bands or other spectrum, the reflectance is high. Whenever reflectance is low, means maybe there are organic content available in that particular site. Maybe water bands are there. Maybe nitrogen is there. So likewise, we can identify through this spectra. So water vapor bands were not useful for soil analysis. So that is what we have eliminated, because our target was to identify the different contents like organic matter, nitrogen, and other parameters. So that is why it was necessary to removing these bands. After removation of this band, we have renovated the data through this formula. For VNIR, 40 was the value used for it, and for SWI, we have used the 80 values. So these features were used, and afterwards we got the pure bands after removal. So only 155 bands were original bands; those bands were used for further processing. And after renovating or after converting digital number into the radiation data, it is compulsory to convert the radiation data to the reflectance data. So either we can do through the atmospheric correction method or other method. So here we have used atmospheric correction, that is quick analysis method. So that atmospheric method we have used because it does not require any type of ancillary data, and it requires only the wavelength of the particular bands or sensors, and even the radiometric calibration with values of sun altitude angle is only required for this method. Even flash is also one of the important method for performing the atmospheric correction, but flash method is requiring so much parameter. So that is why it is essential to use the method which is giving similar results, but using little bit ancillary data. So quack and flash methods are giving the same results, but in case of quack method, this method is requiring only limited metadata. So this method was performed using the function, this function, and we have we can see this figure. Spectral profile of vegetation before and after atmospheric correction. So before atmospheric correction means only radiance values were there. So our steps were identifying water vapor bands and calibrated bands and removing those bands, and then converting digital number into the radiance number. So after converting digital number into radiance number, we can see here is the gap. So here is also gap, and here is also gap. So this value radiance values are not useful for our analysis. So are you doing, for example, you are doing soil analysis or any type of analysis, in that case only radiance data is not useful, because see, there is a gap between number of bands. So here is our wavelength and here is our value. So wavelength is starting from 350 to 2500 nanometer, and at this location, even at this location, there is a no band, means we cannot identify what is the exact picture available at this particular wavelength. Okay, so that is why it is necessary to convert radiance into the reflectance. So after converting data, so see, this is the graph we generated, right? And it is the reflectance graph, as well as we can see it is the continuous gap. So there is no gap between any bands, right? So this is that is why it is important to use the reflectance data and to perform the atmospheric correction on that particular day. Yes, this is important. Spectral features were also extracted through the some indices. Here 5 indices were used: the normalized soil moisture index, then data index, then desertification soil index, and SAVI is also used. The NDVI is also used with this respect to this wavelengths and equations. So normalized soil moisture index was used to estimate the soil moisture. So whatever moisture is there available in the particular soil, those moistures were estimated through the NSMI method. And then identifying dominant soil areas with background and foreground material, as well as to identify the reflectance values in soil areas. So we have used the NDSI. And DSI is for desertification soil to assess the severity of soil degradation. SAVI to reduce the soil background, and NDVI to highlight the vegetation area. So in case of SAVI, we have used some parameters like L value was used, that is 0.5, and NM is the nanometer for SAVI. So some bands like 1800 nanometer for this. See here, 1800 nanometer is one of the region here. That particular region and 2119 region here. This region and this region is given to estimate the soil moisture, because at that particular wavebands soil moisture is there. So these methods were used, and of course dimensionality of the data, because while converting data, while removing unwanted bands and non-calibrated bands, again 155 bands were there. So only some bands are important for any type of study. So remaining bands we have reduced through the dimensionality reduction methods, because whatever input we are giving to the classification method, so dimension, if data is huge, in that case we cannot get the good result, or computational timing will be more, or burden will be more on that data. Even Hughes phenomena is saying that if with increased number of features or dimensionality of data may affect the classification accuracy. So it is essential to convert the data into little bit features or little bit bands, we can say. In that case, we have used the principal component analysis and minimum noise fraction method for reducing the dimensionality of data. And our third case study was spatial feature extraction. So with respect to multispectral data, gray level co-occurrence matrix method was used to acquire the spatial features because it is widely used and having good results as compared to other methods, and it was a efficient method for our analysis. So that is why we have used some of the parameters we have mentioned here. Angular direction 0° was set, 45°, right diagonal was also set in pair of GLSM 90 and 135. So different angles were used in gray level co-occurrence matrix method, and some of the features like mean, variance, constant, and dissimilarity. So these four features were used to acquire the spatial features only. In case of spectral features, other methods were used. And in case of spatial method, this is the proposed approach where increasing window size of that particular method is 3 by 3, 5 by 5, 7 by 7. So as per our requirement, we can change these values. And 8 neighboring pixels were chosen. 4 directions like 0°, 45, 90, 135° were chosen, and some important, again, some parameters were taken with 4 matrices. So these 4 features basically we have used, and we have performed our study to get the spatial features. Means we have identified the boundaries of that particular region through the spatial methods. So that was our main motto, because I want to classify the soil as well as I want to map. So to map it will require some particular region. So through the spatial feature methods, we have highlighted the area of or boundaries of that particular features. For example, soil feature, particular soil boundary were highlighted. Only crop feature, particular crop region is highlighted by the spatial features. Only for extraction of boundaries, we have used spatial features. And then classification was performed. So basically, the aim of classification is to convert the image data into the thematic maps. So that approach was used for classifying. Here, supervised methods, that is maximum likelihood, support vector machine, and spectral angle methods were used. And accuracy is also performed through the and evaluated through the producer's accuracy. These are 4 measures through which we can evaluate our accuracy: user's accuracy, overall accuracy, and lastly kappa. So if kappa value is giving the good value, so in that case we can say our accuracy is correct. Means it is giving the result in the form of either 0 to 1 range. Okay, so if our range accuracy range is near to 1, so in that case we can say our accuracy is good. In our case, our results were near to 1. In some cases it was 0 to 7, 0 to 8, 0 to 9, like that. So those method accuracy parameter methods we have used, and we have generated the error matrix. So through the error matrix, we have identified our results and validated those results. Now, experiment. After using particular device, so that device that is spectral radiometer. See, this is the raw spectra we have generated. Means whenever we scan all the soil samples, this raw spectra we have generated. So raw spectra is converted into the fringe removed spectra, and we got this original spectra. You can see here 74 soil sample spectra is there, and after converting this spectra, after performing pre-processing methods on this spectra, we got smoothed spectra through the first derivative transformation and ASG smoothing method. So here as well, unwanted noise and number of unwanted spectra were also reduced, and only original spectra, average of 10 scans were used here. And the chemical composition. So see here, the statistical result of chemical methods were acquired here. Some mean, maximum, and then standard deviation were calculated. Soil carbon, organic carbon, nitrogen, organic matter, pH values, then electrical conductivity, potassium, nitrogen, Fe, sand, silt, clay. So this number of soil parameters we have calculated, and the result is given here. On the basis of laboratory methods, we have generated one correlation matrix. Okay, so correlation matrix is showing in some case of it is showing positive correlation, in some cases if it's showing negative correlation. Okay, for example, for nitrogen and soil organic carbon, so it is showing the positive result. So nitrogen and the carbon is having good correlation in between these two. So those correlations were used in the developing the particular models. So as I mentioned earlier, water absorption bands were also identified. So those bands were removed. Even clay concentration bands with respect to particular soils were also identified and removed, and correlation matrix was generated. So after generating correlation matrix for particular samples, we got the particular wave bands. So for organic content, organic carbon, organic matter, pH value, electrical conductivity, nitrogen, we got this spectral wavelength. So whatever spectra we have generated here, so at that particular range, so range is 470 nanometer, in some cases 480 nanometer, in some cases 760 nanometer, 832 nanometer. So see here, here is our 50 or 47, 62. So these are the some ranges. So those ranges were identified for particular feature. Both positive negative correlations were identified, and we have detected the more sensitive. So contribution of our study is that to identify the particular wavelength for particular soil feature. So for nitrogen, these four wavelengths were identified as a sensitive wavelength, for carbon as well as for organic matter. And then after developing the PLSR based models, we have performed our results and see based on raw data, whatever raw data, before using any pre-processing method, we have performed the model. So PLSR model was performed on the raw data as well as on the pre-processed data. But for raw data, it was showing the low accuracy. For calibration, accuracy was high, but for validation, accuracy was a little bit low. Because whenever we validate any type of data, maybe accuracy will change in some cases. In some cases, here you can see accuracy is high in calibration for nitrogen, but here in case of validation, it is low. But in case of SOC, accuracy is similar to each other. For calibration, it is 0.72. Even for validation, it is a 0.72. But this range is important, RPD. So it is one of the important parameter for detecting the accuracy of our method. So these RPD values we have generated and we have checked. So somewhere I have mentioned, okay, before it. So this scatter plots we have generated for all these soil samples which we have predicted and mentioned here. So this is the plot, a scatter plot of models which we have generated before using the pre-processing method. So some of the results you can see here. Even 74 samples were used for all the methods, and here you can see RMSVP is high here, accuracy is near to 1, even here also near to 1. So before pre-processing as well, accuracy was good, but after using pre-processing methods, see here accuracy for SOC is good. So in previous case it was only 72, but here it is 90 for calibration, and for validation it is 89. Means pre-processing steps are very much essential to perform or to develop model and to perform any type of study as per our research. So here you can see there is a difference between pre-processing result and post-processing result. See, RPD values are also more here. Here we can see now here one more important point I want to highlight. So this is the table for RPD values. So standard criteria has been given by some scientists. So if our RPD value, if it is greater than 2.0 means our results are excellent. If it is in between 1.4 to 2 means acceptable. If less than 1.4 means the results are not satisfactory. So see here in case of uh, this data, pre-processed data, all the values are more than 1.4. So here only clay is the only one content which is having low accuracy, means results are poor, less than 1.4. See, only 32. Remaining value, RPD values are more than 1.4. Even some of the values are greater than 2. Here 1, 2, 3, some here 4. So these 4 results are excellent, and these remaining results are acceptable as per the RPD values. So we have validated our result with the RPD value. A ratio to performance is the meaning of RPD, ratio to performance deviation. And then we have generated comparative study. So some of the standard researchers papers we have followed, and we compared our results. Our results were little bit better as compared to their studies. And yes, of course, we cannot compare the spatial results with any other researchers, because spatially parameters are changing. Location, if location is changed, results are changing. If satellite data is changed, again results are changing. If satellite data we are taking, for example, current date, and again same locations data if we are taking in tomorrow's date. So again, two data sets, different data sets we are using. Even environmental parameters are also different. So in that case, we cannot compare the accuracy, because in today's condition we will get the good result. Maybe tomorrow cloud may be there. So in that case, our data may be not in the form of good condition to analysis. In that case, our result may be less for same region or with the same satellite. Okay, and if our area is changed, in that case also we cannot have the same results. So it is important to note that whatever models we have developed for Aurangabad region, which is not suitable for any other regions. So remember this. This is very important, as I have referred number of papers. They have clearly mentioned that any model, if we are developing for special purposes, so soil is also one of the aspect of special feature, and crop and different agricultural parameters we can take. So they are varied as per the time, as per the location, as per the device. Okay, so whatever model we are developing, those model will not be used for any other regions. Even the same model for same region will also not give the result after few days. Okay, so that is why it's necessary to generate the good result, give the perfect result. So that is the everywhere science and development. This type of study.
Thank you. Thank you so much, sir, for your briefly briefly teaching us and educating us on this topic. It is really very helpful for all of us. Rucha ma'am, are you there?
Yeah, Shraddha, actually I was not able to attend the entire lecture, so I will not be able to discuss. Yeah.
Okay. So, sir, there is a question from participant side. I guess it's over here. Thank you so much for your contribution. Thank you. So moving on, just wait for 2 minutes. Sir will be joined shortly.
Okay.
Uh, there is one announcement. Our next technical session 4 will be started at 11 a.m. So there is a 15-minute break for the participants. So please rejoin after the break. Thank you.
Is there any question?
Sir, actually, our next session is by another speaker, Krunal Sutha sir. So he will be joined after some time. So there's a break, and this session is continuing. Like there's no another link for this. Yeah.
So I have to continue again.
No, sir. Means are you done, right?
Yeah.
Yeah. There's another technical session. So and that will be delivered by Krunal Sutha sir.
Okay.
Yes, sir.
Thank you.
ના ના હું ના 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 હું 2 વાગે જઈશ. હા અત્યારે ના 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 નહીં જરૂર. હા ઓકે હું કાલે કશો વાંધો પેપર ચેક કાલ પર રાખીશું. કાલે અથવા પરમ દિવસ પર કશો વાંધો નહીં. હા હું 2 વાગે સાર પહોંચી જઈશ નહીં તમારે કેબિને. ના ના ના. હા ના ડન. Hello, am I audible?
Okay, now moving on for our technical session 4. Today, for that, we have with us Krunal Bhanubhai Suthar, Mr. He is currently working as multi-role PG faculty in Institute of Science and Technology for Advanced Studies and Research from May 2016 to till date in Geoinformatics Department, PG Instrumentation and Control Department, PG Physics Department. Sir also worked as UG faculty in Vithalbhai Patel and RPTP Science College, Vidyanagar from December 2010 to May 2016 in Instrumentation Department. His special expertise in GPS and application, spatial analysis, power electronic, utility management in GIS, disaster management using GIS, Geo Web Services, mobile GIS, etc. He organized and worked as coordinator for 50+ workshop seminar with ISRO, IIRS, Outreach Pro in last 3 years. He conducted 10+ webinar for space technology from overall India. He successfully completed international level 2 modules on geospatial application for risk management. In the year 2020, Indian Institute of Remote Sensing ISRO felicitated him as national level best coordinator. He also awarded Gaurav Puraskar by CBM on March 2021. So on the behalf of Anand Agricultural University, we all welcome you, sir, for this technical session 4. You can begin now, sir. Over to you, sir. Thank you.
Okay, thank you.
Yes, welcome, sir.
Thank you, sir. Thank you, ma'am.
Yes, you can share your screen and start the session.
Okay, is my screen visible? Hello.
Yes, it's visible.
Okay, thank you.
Yeah.
Okay, thank you for invitations by Anand Agricultural University on this webinar series. Okay, my today presentations flow will be according this outcome. Then I show the mapping technology for long-term analysis using satellite systems, airborne systems, drones, lidars, then different sensor which is necessary for agriculture mapping. Then show some short QGIS demonstrations for spatial and non-spatial data entry and mapping of attributes. Then I will provide the long-term analysis using the Vedas portal. It is actually designed by our ISRO, and then Earth Data portal by NASA, which is include the different sensor for understanding purpose for the students level, research and planning purpose. Then at the end, each and every system has some limitations and criteria, which is covered in the last stage. Okay, so in these sessions, the participants will learn the satellites and sensor which is necessary for agriculture applications, because the multiple satellites are there for remote sensing purpose in a different applications in a different uses, which is among few are applicable and useful for our agriculture purpose, remaining are for another purpose. The specific scientific data products that are appropriate for agriculture applications for long-term analysis using the web services. So since the beginning of the first persons of the Adam or Eve, whatever you say, it is taught the cultivations for feeding and crop purpose. So still to up to date, we have a large data, right? But some agriculture or farmers use their own predictions, not the scientific purpose. So this is helpful for scientific analysis, yield predictions and forecastings. And then finally, the limitations of remote sensing we will discuss in these sessions. So I'm beginning my session with the mapping technology. See, why we need to use satellites for agriculture applications. It is provide timely, objective, local to global coverage. So from the satellite's image, we can cover a very, very large area. Even the data is stored as an image and it can be accessible through websites or web services. So it is more helpful for timely decisions. For example, some farmers done some crops in a past. He or she can remember 2, 3, or 4 crops if he or she not done documentation work. But here we have a large scale data. It is useful for observing area that are inaccessible. See, using the remote sensing, some jungle area or dense forest area where farmer cannot easily accessible frequently. So those area readings also we can access from remotely using satellites image. Even it is sometimes difficult to understand the growth of the plants in a same farm and neighbor farms with 2-day or 3-day growth. So in that case, the satellite's image reflections is helpful to identify exact the growth on a scientific base. Even we know for the agriculture purpose, soil moisture and irrigations are more important parts. Sometimes over irrigated crop is also damaged, and the stress of the water is also damage your crop, and it is reduce the overall crop yields. So from the satellites remote sensing and from the scientific instrument, we can identify the stress of water in a respective farms. It's identify the soil and crop type characteristics. So it is helpful to farmer which kind of crop is more suitable to respective soil. Even from the Indian meteorological departments, from the weather departments, and from the previous crop styles, we are able to forecast regarding crop disease, crop yield, crop productions. Even the precipitations can be calculated. It is helpful to maximize the crop yield, which is reduce the energy consumptions. Here the energy in the form of the fertilizer, man works, man hours, instruments, farmers, tractors, which are used very nicely and effectively. So it is overall increase the crop production. It is also avoid the unnecessary wastage of the farm inputs. So it is utilized precisely fertilizers, pesticides, waters, and so many things we can be done using the remote sensing and satellites mappings. So the satellites mapping is divided in 3 parts. So mapping is the inputs data. It is used for better precisions. Previously satellites based data have a large coverage, but it's have a lower resolutions. Here, the airborne system is below the satellite systems. So it is almost near to the Earth surface. So it's have a much better spatial resolutions and spatial analysis. So second thing is that in the case of the satellite's image, we have to wait until the satellite pass over your respective farm or respective area once again, because it's have a orbital course parameters. While in the case of the airborne systems, we can fly multiple times as per our requirement. Suppose I require everyday data of Anand Agriculture University, then I can fly my airborne systems every day on the Anand Agriculture region only. I doesn't need to worry for remaining parts. So the height is less, then it is a better resolutions we achieve compared to satellite systems. The next is a drone system, which is widely spreading right now, and it will be boom in a agriculture sector and all the sectors in recent years. So it is a most advanced tools and very, very less costly compared to airborne systems. So it is anytime you can fly and you can got the very, very high resolution, say centimeter level resolutions we can achieve using the drone technology, because drone fly height is much less compared to airborne, and it is almost weather independent. Right now, there's so many drones are available which can be fly even in a monsoons. Just a one small limitations of the drone is a wind directions and high velocity of the winds. It may be compensated by so many gyroscopes and some parameters and control of the propulsion systems of the propellers. So it is most advantageous But there is a limitation, is that the fuels or its battery charging, which is a short flight time, is provided hardly 30 to 40 meters, depending on the drone size. So drones are widely used and less costly compared to airborne and satellites. But if you think a large area coverage, or for entire India or for entire global, the only satellite systems is cheapest compared to any systems. But here the drone system is cheapest with context of the small region or our own area only. So the most advanced sensors right now is a LiDAR. LiDAR is a mostly utilized in a drone and airborne systems, right? So it is a one of the latest tools which is provide you accuracy of the in millimeters. So it is used for very high and precise accuracy. LiDAR sensor can be fit to drone, airborne, or even the large scale. So LiDAR is further divided in a ground platform, drone platform, and airborne. So we learn both the drone and airborne. The ground platform means you can utilize the any high platform and where you can fit the LiDAR, or you can put on the tripods, and LiDAR can scan the images. But LiDAR sensors are very costly, right? So it is a basics for platforms for measurements. So now we require to measure the specific crops. So if you see the history, the Landsat 1 is originally utilized in the past 1972 as a for agriculture purpose. So you can say Landsat 1, which original name is the Earth Resource Satellite. It is the first satellite in the history of agriculture mapping. So its spectral range is 0.5 to 1.1 micrometer, which is provide a 3 bands: green, red, and infrared bands. So it is a first satellites which is used for agriculture mapping. It is a first Earth observing satellite to be launched with the express intent to study and monitor the planet's landmass, development of crop production forecasts using satellites monitoring, and for the global agriculture systems. So it is a first satellite in the history of the agriculture. So we are back to our different sensor systems. As we discussed, the multiple sensors are there for temperatures, for infrared, for precipitations, for soil moistures, right? So among them, for the better crop analysis, land surface reflectance are very important. So land surface reflectance is originally used in the case of using a MODIS satellites. MODIS full form is a moderate resolutions imaging spectral meter, and it is using two different products, Terra and Aqua. So MODIS band 1 to 2 provide 250 meter resolutions, and band 1 to 7 provide 500 meter resolutions, while band 1 to 16 provide the 1 kilometer resolutions. So Terra and Aqua provide the land surface reflections almost every day. You can see those things. I will show you at later stage the physical demonstrations practically. Then second, for the land surface reflectance is a visible infrared imaging radiometer suits. So it is an instrument on the NOAA platform for Suomi National Polar Orbiting Partnerships Program, and its spatial resolutions is a 375 meter and 750 meter resolutions. A spectral resolutions, it's have a 22 different band ranging from 0.4 micrometer to 12.5 micrometer. Its temporal resolutions is daily, 8-day, 16 days, and monthly, and it is based on your resolutions. So the VIIRS data is available since 2012 to up to today, and it's have a global coverage. The next is a land surface reflectance from the Landsat 8. The Landsat is launched in 2013. It's our two instrument, OLI and TIRS. The OLI means operational land imager. Landsat data have been produced, achieving and distributed by the Geological Survey of USA, This is built on 15 years of the Landsat program and offering the largest and longest continuous global coverage. So Landsat 8 is provide the spatial resolutions in the range of 30 meter. It's have 9 different band in the wavelength from 430 nanometer to 2219 nanometer, and its temporal resolutions is around 16 days, and it's provide the data up to today. The second is a thermal infrared TIRS, which is also useful in a same platform from OLI. The Sentinel-2 and Sentinel-2B data is most precisely used, and it's available. Sentinel-A 2A is since 2015 and 2B is since 2017. So it is a constellation of the two polar orbiting satellites, which is same on the sun synchronous orbit with the phase of the 180 to each other. So this Sentinel data is more helpful. Next is a multispectral instrument known as a shortly MSI. So its spectral resolutions is a 10 meter. It is available in a very near infrared range, in a 20 meter resolutions in a red and short wave infrared, and 60 meter resolutions at atmospheric band. Spectral resolutions it's provided under the 13 bands from VNRI to short wave in the wavelength from 0.40 micrometer to 2.2 micrometer. Its temporal resolutions is 5-day, and the MSI data is available since 2015. The Sentinel-2A products provide ortho-rectified bottom of the atmosphere, in shortly known as a BOI reflectance, with the global coverage. The next is a Evapo Transmissions. So some of the evaporations from the land surface plus transpirations in the vegetations is highly variable in a space and time. So critical component of the water and energy balance of climate soil vegetation interactions is important. So extremely used is monitoring and assessing the water availability, drought conditions, and crop productions. So remote sensing has a long been recognized as the most feasible means to provide the spatial distributions region informations over the land surface. It cannot be measured directly with the satellite instrument, but moderately instrument output are depending on the mainly variables. Those variables are land surface temperature, air temperature, solar radiations, humidity, albedo, soil conditions, and vegetation cover. So satellites and sensor for evapotranspirations are a MODIS. So MODIS 16 number bands provide the level 4 products. It's a evapotranspirations or latent heat flux. It's have a 8-day temporal data and yearly intervals available. The spatial resolutions is a 500 meter, and since 2001 the data is available, so we can imagine the 21-year evapotranspirations data is available for the analysis. The next is a ecosystem it is a ecosystem spaceborne thermal radiations experimental on the space stage. It is known as the ecospace systems, which is also useful for the measurement of the evapotranspirations sensors. The next is a land data estimation system. It is known as shortly as a Ldas. So land data estimation systems provide model-based data of which there is a global collections and North American collections, which range is a 16° north to 16° south. Integrated satellites and around observations with a sophisticated numbers model based on water and energy balance method. So it's provide spatial resolutions in the degree of 0.25 degree to 1 degree, and its temporal resolutions is very quiet since 3 hour daily and monthly. So 3 hour temporal data you can imagine in the daytime, in the daylight time and night time we can separate easily. And this data is available since 1948. The next parameter is the land surface temperature. We know the higher temperature and lower temperature affect the crop productions and yield, and temperature is directly associated with the evaporations of water. So land surface temperature is known as a LST, and it's produce the temperature of the land surface. Mostly in the scientific matter, it is measured in the Kelvin scale, but location wise, it may be in centigrade or Fahrenheit unit may be utilized. It's differ from the air temperature measurement as it is provide the temperature of whatever is on the surface of earth. It is a bare sand, it is a snow cover area, leaf cover, tree canopy, road, etc. It is useful for monitoring change in the weather and climate pattern. It is widely used in agriculture and water resource management to allow farmers and decision makers of the large scale of a district or state-wise to evaluate the water requirement. It is accessible from the Modi's band number 11, which is provide the land surface temperature and emissivity with the level 3 products. It's available from both the Terra and Aqua satellites. The temporal resolution is a 8-day or monthly, but its spatial resolution is little bit poor. It is a 1 to 6 kilometer, but it is a good for the regional analysis. And the Modi's band data is available since 2002 up to today, and it's provide the global coverage. The next is a visible infrared imaging radiometer suits, shortly known as a VIRS, which is band number 21, is used for land surface temporal and emissivity. It is also 3-day production, level 3 productions. Its temporal resolution is same almost as a Terra and Aqua, daily and 8-day, but its spatial resolution is quite good compared to Modi's, and it's provided up to 750-meter resolutions. And the availability of those data is 2012 up to today. The next is a precipitations. It is a key for component of water cycle and difficult to measure since rain and snow vary greatly in the both space and time. So satellites provide a frequent and accurate observations and measurements of rain and snow around the planet or respective region, especially where ground-based data are sparse. Radar radiometry estimations measure the intensity and variability of latent heating structure of the precipitation systems. Agriculture community needs to know the limitations and amount of the rain or snow to forecast the crop yield as well as freshwater shortage and affecting irrigations and productions. Among them, the satellite sensor for the precipitations is Global Precipitations Measurement, shortly known as a GPM. So it is designed those sensor by NASA and Japanese Space Aeronautics Agency JAXA. So it is an integrated multi-satellite retrieval for global precipitations measurement known as a imagery products, and it's provide a 0.1 by 0.1 grid resolutions between 16 degrees south to 16 degree north. And this is a level 3 data, and it's availability of the data since 2000 year, and the data is available after every half an hour for the global coverage, and this data is free to access. The next is a climate hazards group infrared precipitations with spatial data, shortly known as a CHIP RPS, which is provide the rainfall estimations from rain gauge and satellite observations. It is developed by Climate Hazard Center of California and incorporated in-house climate metrology with 0.05 degree resolutions in the infrared band, and it is a in situ stations in the global. Its coverage is 0.05 degree to 0.05 grid accessible, and since 1981 to up to today, the data is available. The next is a soil moisture active and passive maps. So L band provide the passive radiometry receivers energy in a narrow microwave band 1.41 gigahertz range, which is also level 4 product estimations map L band brightness temperature data into land surface model generations. So this data resolution is very poor. It is around the 9 kilometer resolutions, and the data is available after 3 hour daily accessibles. The next and the last is a Ldas. So land data estimation systems used for numericals model and integration satellite informations with the ground-based data. Its output estimations of the soil moisture, temperature, and evaporations. So I hope you able to understand the different sensors which is widely available as a open source for the accessing and measuring of the agriculture parameters. So most widely used and most of the students are available with the technology of NDVI and different accessible bands. So we know the NDVI is a nothing but difference of near infrared and red with the ratio of combined. So it is provide an information regarding the absorptivity of the infrared, red region and green band. Here, the most green plant absorb the red band and reflect the infrared band. Near infrared band is reflectable, while the water strays or yellowish crop absorb the less amount of the red and reflect the less amount of the infrared. So you can directly see the comparisons of percentage, and it is totally depend on the chlorophyll inside the leaves. So the range of -0.1 to 1.0 NDVI is used, and 0.9 is considered as a very dense green coverage or vegetations, while -1 is a non-vegetation surface or it is a barren or open area. So this is the most widely used to measurement for the green biomass, season change, and for the climate conditions. And its spectral signature is drawn down with the different wavelength, which is helpful for different kind of the crops, and among them different reflectivity and absorptivity is helpful to identify the crop conditions. So this is a summarization of the different sensors available for the measurements and readings for the agriculture region. So once we have a agriculture data from the different sensor, as we since it is available since so many years, and it is helpful for the planning and analysis purpose. So once we done the analysis, it is helpful for the future forecasting. So there is a two different way for the analysis methods. One is using the QGIS and ArcGIS softwares. QGIS is an open source software, while ArcGIS is a proprietary software. It is used for very small scale, or the farmer can use own data, and it is limited to own farms or small area, but it's required continuous adding the data. I will show you in the next stage how we can be utilize QGIS for analysis purpose. It is also used for small region or block analysis or city analysis. but where you have to manually continuous enter the data in the attributes. While another is a web services. The web services is the satellite's data is continuous tracking in a servers, and those free data is available on the geo servers, or known as a web services, which is utilized for large area coverage, for a large farm or long-term predictions. It can be easily utilized using the web services. So it is mostly managed by the different government and agency. In the India, it is managed by ISRO, and one of the web services from the NASA is nicely available for each and every person, even without the logins. So it is useful in the future crop yields and commodity analysis, because based on the our India, the crop productions, the commodity markets are running. So let us see the how it can be used in a QGIS. I already kept the open to save the time and easily presentations purpose. So let us see how it can be useful in the QGIS. Here I assume you are little bit familiar aware about the QGIS open source tools. So here I take the small region as our forms for the measurement analysis. So just I'm providing the paths from the desktop and adding the my form which is created files. So here I am adding the my files of the forms with the different region and shapes. I ignore the roads and etc. So you can imagine if I just click on the any feature, it's provide the different informations which is available, right? It is deselecting the all layer and put on the maps. So this is the considering the form boundaries. And if we open the attribute table data, so in the attribute table, it's provide the area parameter, and for the security reasons, I remove the all the data because it is a undergoing projects. So what is we can insert? So a farmer or local authority have to add how many times fertilizers is given to respective farm, when they provide the water, when the seeding was planted with the date, instruments available for measuring the soil moisture, temperature, even from the IMD data or some another weather forecasting data, we can measure the sunlight, because the availability of the sunlight is more important for the crop productions, crop cutting dates, soil nitrogens, its humidity, rainfall, and so many parameters data we can insert in the systems. So this is the one kind of the attribute table, and here it's provide the querying systems, means you can select the largest data, smallest data, average data, just simple as in a information systems. We are generating query in the servers or in a Excel sheets or whatever. So this is helpful to identify the last date for watering, uh, lowest amount of the nitrogen, lowest amount of the CO, lowest amount of the fertilizers, date of the seedings, height of the plants, etc., etc. We have to insert, and this is the helpful for our local air analysis purpose. So here you can measure the area and its parameter and inserted amount. So automatically the ratio is calculated, and for that we have to just simply click here and it's provide the feature selections and generating the query using the multiple query, and its path is available. Even the non-programmer persons can be directly perform the queries, and those part is easily available on the features. Another is that the part is watering is important. So we have also one network is a water network. This is a Narmada water region and it's a coverage. So you can see the layer is added here. Sorry. So we can see easily the reduce the background transparency. So we can easily see the canal networks. Here we can also change the symbology and labeling as per the requirement. So we can easily monitor and see. So you can easily see the coverage of the available canals network, because the canal is a main source of the irrigations for our systems. Because all farmers not able to financially bear the own borewell or systems, or sometimes borewell is not enough to provide the large region. Even using the measurement tools, we can measurement the length, area, and perimeter directly from the updated data. The next thing is that a DM data. DM data is helpful for the respective region, and this data is available from the satellites and lidar sensors or from drone based systems. So you can see here, this is the provide the informations which is helpful to find the contouring, right? So just on the one click we can find the contour, and contours are most helpful to find the slopes. Just in a raster, I am trying to extract in the front of the contour, and I can put the contour elevation is 100. So it will start the extracting and provide the slope, because slope is more helpful for the growth. And as a part of the biogeographer, sometimes the sunlight is very important, because in a two different directions, north facing and south facing or east facing, slopes have a different quality of the crops. Agriculture or biogeographer easily can estimate the amount of the production and crop yield and quality of the crop. I'm sorry, it's taking some much time because system is occupied. Just wait for a while, and it's provide the output of the contouring, which we can see easily on the map just on a few clicks, and it's helped to provide the slopes. It is running a little bit slower because system is occupied for sharing the graphics card, net, and multiple applications are running here. So that's why the system is a little bit slow for the running. I just forget to extract the contours. I think I'm omitting those parts because of system is running. Let me see, suppose if I save the contours. Sorry, I'm not saved, but I hope you can understand. Using these options, you can extract the contours, and it is available for region, right? It's taking much time, and due to the time limitation, I'm just omitting. At the end, if the time is permitted, I will extract the contour and show you here. Still, we can see the another options. As I told you, it is helpful for the directions orientations, and you can easily see. So here 45 degrees mentioning your altitude of the sun, and the azimuth is provided from which direction sun is looking. So just right now consider the 0 degree. So 0 degree is informations regarding the sunlight is available from the north side and at the 45 degree. So it is provide the informations on the land surfaces where the sunlight is focusing, because in the presence of the sunlight in a 3D glacier, we can see easily where the crop production is much more, because some crop require large amount of the sunlight while another crop is require shadow, or once the crop is a growing age or mid age, it's required less amount of the shadow. Suppose this is the orientation from the north directions. You can see this white part means from this upper side the light is going. So based on your farm or surrounding terrain or based on elevations, it can be changed. I am just taking directly exact opposite 180-degree, so it is highly visible in the this image. So just I am applying right now, so you can see the shade is totally changed. In the past, this side upper side is looking much white. Now it's become a black because I am taken the 180-degree. So the presence of the sunlight is also impacting on the based on our ground surface. So I hope you understand. Using this tool, we can provide the informations of the availability of the sunlight, and it can be vary with the different angles and different zones. Okay. The next thing is that this tools is also helpful to provide the 3D animations of the our systems. So it's taking some time because two parallel systems are loading. I am just canceling the extraction of contour. And just opening the 3D modeling. Just system is not responding. Sorry, my system is hang. Here, I hope my screen is visible.
Yes, sir.
Okay.
Yeah.
So just wait or just 2 minutes maximum. I'm just opening. It took some time for the loading, but it will be there. So 3D modeling is widely helpful for the slope and aspect analysis purpose, and it is given farmer information about the flow of water, precipitations, and evaporizations. This is the open source software which is available on the net. You can just write QGIS download and you can access. It is a free source. Okay. I think my screen is visible, right?
Yes, sir.
Okay. See, I am just representing the one area, and you can see the digital elevations model, and we can extract in a 3D model too. Sorry, image is different, maybe. Yes. So you can see there is a 3D terrain model, right? And it is a helpful to find the flow and slope. I've just put the very small scale so we can easily visualize the change in a slope model. I hope you are able to see. Can you see the change in the slope flow in this 3D model? Hello. Is my screen visible? I hope screen is visible, and we can convert into 3D and twin model too. Just by simply converting, we got the modelings, right? It is data available from the Bhuvan store and easily accessible by everyone. So after QGIS demonstrations, we require to insert the multiple data in the attribute which is I explain you. So soil moisture, rainfall, vegetation type, temperature. Once we all those data insert in a QGIS attribute table or sheets, it is a one kind of the Excel sheets. So we can find the best way predictions and analysis. The next is that based on web services, which is based on the web services. So I begin with the our official Indian websites. So it is a vedasac.gov.in. Here you can find the large number of the applications, but as per the theme of this webinar, we go with the vegetations and crop monitoring. So this data is open source and everyone can access. So just I am focusing our region on agriculture as a part of the theme and experiment purpose. So here we can visualize our Anand region in a Gujarat. So here somewhere we have our agriculture university of Anand agriculture. Now this is provide the multiple references, a layer, say administrative boundary, base map. It's a labeling. I'm removing some labels, or I can add. Even I can remove the base maps and boundary, city level, village level, taluka, district, etc., etc. But as we increase the number of layers, it is increase the but it is increase the burden for the loading purpose. So it is also provide another infrastructure, railway, airports, and national highways. So we can utilize which is the nearest to us. We can turn on and we can turn off the manually requirement. Say this national highway 8 is visible here. If I close, it is not visible. We know the railway tracks is passing from the near agriculture university, which is also visible here, but I am removing which is not required. Now the imaginary. So in the beginning, I was explaining about the different sensors. So which sensor data you like to be used? For example, Moody's data, Sentinel data, AFIS data, you can select the dates of the previous dates for the analysis purpose. Suppose I'm choosing the 6th May for the analysis purpose from the Moody's and 9th from the Sentinel. So suppose I am expecting the Moody's data and I am go ahead even the other satellites data is also available for the different analysis purpose. Here for the crop type and its analysis for the region wise. But once I was selected as my imaginary, as a Moody's data, I go with the data visualizations. So now it is expecting, as per my resolutions, I should be clicked somewhere, just considering this greenish dot. So this data is available under with me with AFP's calculations. So this data from since 2011-12 crop to up to 2021-22. So last 3-year data is visualizing using the 3 different legends: red for 90-20, light blue for 2021, and dark and width with 21-22 is currently going on. So you can imagine the high reflectivity and low reflectivity. So you can see between the 2014 to approximately 2017, the crop output is much higher, while in the beginning of that 11-12 it is a continuously up and down. So even we can see that today is a 10th May, the 8th May data is generated using those analysis. So since the previous data availability, we can analyze. I can change the layer from Moody's to Sentinel and apply for same imagery visualization, right? And see the change in the patterns. Sorry, I have to click, then only data is available. So you can see the change in the pattern. In the 2015 onwards, the data is higher. Now we go with the some another region and you can see the chart. So this data is available. It is helpful for all the purpose: agriculture, finance, banking sector, and even the PMKSY insurance company, right? So this is the widely available data for the analysis purpose. The different layer you can add and you can see. Crop culture purpose, suppose let's we go with the Gujarat and we can select the type and its availability of the year. Suppose 1890 and we select the region is a Anand. So we can see the legends, and if we go with the data visualizations, it's provide an information regarding the wheat crop. See, so this is a more helpful tool for a long-term data and analysis purpose. Even the data analysis tools provide the date. See, here it is help us to compare the two images, previous and current images. For example, I am enabling the swipe mode. So it is provide me left and right. In the left mode, suppose I choose 2021 May data. Okay, it's December, right? And in the right map, I am choose the current data. So now you can easily visualize the change in the agriculture, because December is a more weight and have a high NDVI. So you can compare the images, right? So it is a Moody's image. We have a Sentinel NDVI for the same thing. So you can compare the productions and its crops. So this is a nice tool for the long-term analysis from the Vedas portal, and it's have a multiple sensor. So district level, taluka level, SAR, whatever you like, you can just select a water, spread, crop, RGB, and you can perform. I hope it is a more helpful to you and for the your future projects works. So it is available under the Vedas Sec website and as a part of the vegetations and monitoring crop. Now the second site is a by NASA, and it is available for very large scale. So its name is a worldview.earthdata.nasa.gov. This is also one of the open source site, right? Among them, it is a initially load this window and provide the informations. Here, this window, it helps you to pop up the introductions about the worldview and or how you can use. But I'm just omitting this part so I can show you fastly. See, it is provide the live data of the multiple satellites. So among them, you can see the Terra is complete up to today analysis from here. This is the date line, and here you can change the month and date for the things. Now, the question is that you are not a GIS or remote sensing or satellites information students, but you are a based in a agriculture and you require to access a specific informations. Now I request any participants, please suggest me which informations you required, which is I bring you in front of you just in a few seconds. Which parameter you like to access? Anyone, please? Here we can also add the label, we can remove the label, and just we are focusing the our Indian region, right? So it is better to understand. See, I'm going to just one day back, so I have an entire data of the Modis, right? See, suppose I like to measure precipitations. Just I need to click here, add layer, and all the possible different layers are available with the scientific instrument. But still I am not aware about that. Just I considering for flood, drought, air quality, fire, aerosol, etc. Doesn't matter. Just need to type precipitations. So it is already provided the different precipitations rate using IMER satellites, using GPM sensors for rain rate, snow rate, surface precipitations, nighttime, daytime. Just you need to select, and just based on, suppose I'm selecting the one, it is provide all the technical data on the right side. So this is available since 2030 May onwards, and its technical parameter, resolutions, and informations. Once I click the here, it is available under the my menu. I just close and I can see those layer of different days. See, and its rain date is also available and snow is also available. Right now we are in the month of the May, so rain is not showing here, but it is showing the Asani cyclones, which is going to be impact today. So you can see the possibility of the rain forecast from the here. But suppose we go with the our 2021 and go with the November or October or September or August, which is provide the rain forecasting informations, our region, and precipitations of the waters. If I don't like, I can close or I can remove the layer also. Suppose we like to add the layer of the land surface temperature, LST, reflectance, land surface temperature, LST. Daytime temperature is different, nighttime is a different, and as per the accuracy requirement, they provide the from multiple sensor and multiple. So suppose I choose the land surface temperature, it's provide the informations. Just click here and the layer is added. So we can see the land surface temperature for 2021. We go with the 22 and we know the temperature of previous day using the legends. And now just I simply jump to January or March. So we can compare the temperature, sorry, not a May, January 9. So there is a 4-month gap and we can see the change in the temperature, right? And suppose you like to compare with the analogy, it is also provide the comparisons option. See here. Here January 9 and here January 2. Suppose I select the second layer and choose up to the current May. Now you can easily compare. Even we can zoom level as per our requirement and see the significant change, but its coarse parameters are less. I hope you able to see. So from here you can compare the any layer, not only temperature, which layer you added, it can be compared. See, true color aqua comparisons for the analysis, right? So it is a provide the informations for conversations. Suppose I want to check NDVI, normal difference and vegetation index. It is a monthly basis. I just added and its information available. Now I go with the previous day and reduce the scale. We can see vegetation index. It's based on your internet speed and the information is provided from the NASA server, right? Closing reflectance, closing reflectance. So just we are waiting for vegetation index. It's taking much time. You can see it is a loading. Suppose if you found any query, yes, on the I button, it is provide the help for that it is available since 2000 up to today. And is a Moody's 13 band. I'm not sure, but something is wrong with the systems or server. Just remove and add once again. And DVI vegetations from the Aqua and Moody's. For reflectance. Yes, it is visible. So you can see from the previous date, NDVI, see in the April, and just we directly go to the 2021, not a May, July, August, September. So we can compare directly, right? Using the start comparisons. Even you can make a visualization purpose, how the NDVI change or any patterns is changing for demonstration purpose. This video tool is helpful for the setup the animations. Since just I choose for the fastest way purpose, 2020. September is not there. That's why it is a creating problem. January and September. Okay, just you start the playing. It is start the preparing and create the entire animations. January to September, and you can see as a changing the frame rates, changing in a vegetation index. So we have a long-term analysis data is available since 1948, and you can even export those animations. I'm just pausing, and we can export it here as per our requirement. We can download, we can check the another events, and this is a helpful for the analysis. So all those data is a free of cost and available easily on the web services. So there is a thousands plus layers are there, and which layer you like to measure, you can access.
Dr. Suthar,
Yes, sir.
can I ask small, can I interrupt
Yes,
you
please,
for a
please,
moment?
please. Sure, sir.
Uh, in fact, I'm living in Anand,
Okay.
and if I want to monitor my farm by sitting 100 kilometers away from the farm,
Okay.
the village name is Kareli.
Okay.
It is in the Taluka Jambusar district, Bharuch.
Okay.
Can I monitor that their operations and then the vegetations and everything?
Actually, it's depend which parameter you like to measure. In the beginning,
Like
I
what
told,
exactly, what, for example, if I want to monitor whether he has done, I mean, vegetation sowing has been done or not. Let us say some vegetation, what is the stage?
yes, definitely.
Some
You can
okay.
use the NDVI, water precipitations, right? And just you have to enter the name, or you can enter the latitude longitude. See, I hide the multiple layers so it can run fast. I just turn on the labels. So it is start providing me the informations of the places label, coastline and borders.
So
you
it will monitor the village also, no? It will monitor the
everything.
village level farmers.
See, based on your satellites. In the beginning, I explained the different sensor and it's a different limitations of the resolutions, right? So based on you can access from anywhere, and almost it is provide up to today latest data. See this sites, and it is openly available for everyone. See, up to today you can see which data is acquired by Terra Modi's Reflectance. Just wait for loading. Right now we are accessing from around 12 o'clock. If you see after 2 or 3 p.m., you can found easily this line is also acquired by orbital path. So it is start from the morning, you can say like that, right? Ascending, descending node. So this is almost true time data, and almost for the analysis purpose, we are not live monitoring actually from the satellites, but it is helpful for 1 or 2 day previous work. We can easily accessible. Who is working in this field, they have an idea how costly data, and it is difficult to access the data. Once you receive the data, then it is difficult to previous comparisons. So that's why it is a long-term analysis available from the worldview and our ISRO. So we can predict the multiple things. And just you need to type which information you require to acquire, like water, fire.
Now, for example, what is the soil moisture status right now?
Yes, soil moisture, right? It is a multiple soil moisture. So now you have to study which satellites information is useful for your region and what is the accuracy. Nighttime daily, daytime daily. Downscale means it is a reducing from the descending ode. Multiple sensor from the multiple satellites from the different countries. It is provided easily, weekly, monthly. So you have to just click on that and study. Information is freely available here, and you can put on that. Right? It is a 9 kilometers path. Yes, please.
Why I'm asking, because the soil moisture and soil nutrient that decide the crop.
Exactly.
So the farmer knows what is the balance of the moisture, what kind of crop is being used for the moisture use, what kind of crops can be used for the nutrient uptake. It's basically nutrient balance and water balance.
Exactly.
Now by sitting here 100 kilometers away from Anand, can I monitor what is the status of the soil, what is the status of the crop, what is the status of the water?
Exactly, so you can access.
So can you teach me? I don't know how to, I don't know how successful this.
Just it is a soil moisture. I'm just clicking adding the layer, right?
Okay.
I click here. It is added, and up to today the soil moisture is visible.
It can show the village also. No?
Yes, sir, definitely. But today's data is still not scanned. So just go with
Okay.
the yesterday data. So we
No
can
issue,
see.
no issue, no issue.
See, here I just changed the yesterday date, right? And the second limitation is the satellite itself. You can see there is a patches between the satellite's path. Suppose
Right,
sometime
right.
it is also possible our region is not under this path. Suppose your area is somewhere here. Suppose. So on the 8th May data is not available, but 7th or 6th data is available.
That's
Right?
fine. That is fine.
So we go with the yesterday data
Mm-hmm.
and just entering here.
Oh.
Now at least we know the our geography, right?
Mm-hmm.
And I change the layer and label is on. It is not showing right now. Now this reflectance is close. So let us see. We going for the soil moisture and GCOM with AMSR satellites. So it's provide the information. Just 1 second. Delhi. Its value is under the gram per centimeters cube. But here, okay, the resolution is a 25 kilometers.
Fine, no issue.
Right. So we have to choose another sensor which resolution is more better.
Okay.
So there is, I told in the beginning, multiple sensors are there. As for the orbital height, orbital periods, the spatial resolutions are changed, and we know very well it is totally based on Earth observations data. So
I could see a lot of potentiality of this your applications. Maybe
this is not my application, not my application. It is designed and maintained by NASA, not mine.
Fine.
I'm just demonstrating it. So researchers or students can easily access.
Yeah.
Right?
I'm thinking in what way we can use this as a farmer's level. That is what my question was.
Yeah.
So I was just thinking in that line. So
in the
I could
large
see a lot
area,
of
as a
potentiality.
difference maker, you can compare the this year's and previous years and provide the information. Last year, almost the seasonal crops are almost repeating. Hardly 1 week to 1 month gaps are there. So we can find from here what is the situations change in the analysis, or what is the watering they done or nutritions they done, right? So, see, almost we keep the May month, but if we go with the April or June, where there is a possibility of the change in the stress, and with the legends we can access.
Very good. Very good.
I hope I satisfied your answer.
Yeah. Thank you.
Okay, thank you. So it is a web services for long-term analysis. So not only this, but so many systems are there. One is the Vedas I shown you, Worldview I am showing you, Bhuvan. If you are a good Python or JavaScripter, you can access the Google Earth Engine, Copernicus, and so many web servers are there, which is provide this kind of the informations. And using those things, we can analyze our data. But just due to the times of limitations, I just show you the only two. So as we access the information from the satellite, but each and every system have some limitations also. So it is difficult to obtain very high spectral, spatial, and temporal resolutions with the same instrument, because in the beginning I told you it's vary from 1 day to 16 days. And for the same spot, yes, the satellites are in the orbital course and they are moving continuously one place to another place, but for the revisit and repeating time is different from satellites. Optical sensor cannot be penetrate clouds or vegetation's cover, which can lead to data gaps or a decrease in the data quality. Optical sensor means our simple human eye, which can we see, and our farmer is more dependent on the eye, and they depend on the data informations what they can see, but they cannot be directly see the water stress or anything others without infrared or red band differentiations. So optical sensor is difficult to establish which human can see or which is help to consider the thematic maps. Spatial resolutions, which codes resolutions of MODIS and VRS provides a synoptic view. The spatial resolutions are two codes for field level assessment, except you are working for a large scale. That's why the new technology of drone and the same sensors or payloads are available, which you can fly and you can access, which is satisfied the problem or limitation of the satellites as a temporal by drone. In the past, the drone was not established. The only airborne system was there. And we know the flying the one airborne system per hour is 2 to 3 lakh rupees cost. But compared to drone is a, compared to airborne system, the drones are very, very cheapest for the repeatedly data. You can even the fly morning, noon and evening after charging or every day. So you can create the large temporal data of respective farm or small scale. And the current drone easily cover 4 to 5 kilometer area, and drone spatial resolutions is available with the good quality Ninja and the Monder's drones is a 3 to 4 centimeter level. Spectral resolutions is one of the questions once again, because all the sensors are not available in the all the satellites. But suppose you are interested in a specific trace of the water only or and nutrition only, then respective sensor you need to find and you can put and you can complete your work. And it's require large amount of the data. So you also require to learn to manage, store in the servers or information systems, size and analysis. So it is not only one person's work, we can say. Actually, it is a teamwork for the all. Because I am not an agriculture person, but as the requirement, I can analysis and I can find. But the agriculture persons or farmer can do better way what they can feel. So it is a teamwork of the space technology, information technology, and agriculture is which is really helpful for the future, which is helpful for the crop monitoring, crop forecasting, market stability, humanitarian ads. We can access the multiple informations like leaf area index, photosynthesis, fraction of the observations, and FARPAR and BDR, multiple things we can access, right? So here I conclude my sessions and it is open for question answering, please.
Dr. Kunal.
Yes, sir.
Very simple questions I am asking. Can we monitor what are the crop being diversified in last 5 years? Which
yes,
region
definitely.
Which region has been shifted to what? For example, I have been reading this news clipping that in Madhya Pradesh, that wheat has been replaced by soybean.
Exactly.
And some of the area like Saurashtra region, I mean, some crop like groundnut has been, it's a major one. Some other crop has been diverse. So can we see by looking the satellite images, can we do, I mean, is it possible?
Yes, definitely. So I'm presenting. I hope my screen is visible.
Okay.
It is done by our ISRO scientists and available on the portals. Just add the reference layer and say crop horticulture. Among them, suppose we go with the Gujarat. Sorry, you are looking for Bihar, right? Hello.
Any state you can take.
Yeah, I just take a Gujarat. Among them, wheat and mustard is already done. Suppose we go with the Punjab, then let us see. It is only wheat purpose for 2016-17, right? And if we select the respective region, let's go with the Gujarat, and wheat and mustard is available, and just I can enter the choose the locations, or I can manually enter the latitude longitudes for respective crops, right? And I have to enable the different layers. Just simply I go to data visualizations and click on that.
I want to see a state as a whole, not individually location, state as a whole.
State as a whole, for that we have to go for the image analysis train model. Just identify the as a machine learning. Sorry.
Like for example, in
I got you. Different farmers are doing change the patterns, right?
Yeah. So yes, what are the state as going for what kind of crops?
Yes, we can access definitely. For that, we have to go for the machine learning. We have to just suppose this area, I choose the one crop, right? And its reflectivity I measure out. And I apply from where the same reflectivity I'm getting. So all the same farmers done the same crop. Remaining farmer is doing something different crops. So for the specific crop analysis, it is reflectivity is available from the spectral signature. In the beginning, I was mentioned, this is known as a spectral signature reflectivity. See, I'm enlarging the my sign. So on which wavelength it's a higher reflectivity and low reflectivity, corn, tulip, and soybean. So this reflectivity is reflect the respective crop and which provide the information the respective farmer done this crop. Got it?
Yeah.
Okay.
Okay, sir, there is one more question.
Yes, please.
Is VIRS data sets are freely available or not?
Yes, freely available.
Okay, okay.
Which
There's-
sensor I mentioned are freely available, but just limitation is that maybe very high resolutions data is not easily available for the common or civilians. You go with the 750 meters or 1000 meters.
Okay, okay, okay. Sir, the next one is which data sets are based for daily precipitation measurements? Precipitation measurements,
See, I
soil
told you,
moisture measurement.
as mentioned, there is a multiple sensors are there.
Achha.
Its accuracy is based on your requirements, your locations, geography, weather, everything is affecting, right? Because
Yeah.
calibrations and validation is done based on available data and sensors calibrations.
Okay.
So
Okay.
for that, you have to learn all the sensors and compare with yourself in your region.
Okay, okay, sir. So, sir, can such software is equally helpful in drought affected areas?
Yeah, definitely, because whatever this is one of the satellites data I extracted
Okay.
here.
Yes.
Just wait. I have just connected with the WMS services with our Bhuvan server,
Yeah.
right? Yes, I'm trying to connect. It is for those who is aware about the web services, geo web services. Bhuvan is maintained by ISRO and NRSC Hyderabad.
Okay.
Right?
Yeah.
With some small scripting required there. I already put all scripts in my systems. See, it is around different 7,916 layers are available, right?
Yeah.
Now suppose I want to go with the water. So among them, it is provide the PMKSY water, water bodies, water quality, etc. layers are there. Agree?
Yeah.
Can you see?
Yeah. Yeah.
Yes, I randomly choose for the anyone. Say PMKSY water body. I just double click and say add.
And yeah.
Close. Just waiting. It is going to add. It will be added here soon.
Okay.
Even you can mention your land use land cover. My system maybe once again hang because little bit multiple systems are multiple applications are running parallel. Yes, water bodies are there. I remove, and here you can see the water symbology zoom to layer for entire India. So it is directly accessible in our QGIS system, and QGIS is an open source. And this is a Bhuvan's web services are also open source for so many applications, not all.
Okay.
So it is a loading from the Bhuvan server, Indian ISRO server. Just wait. Yes, you can see. Okay.
Yeah.
So the tools is also same helpful. ISRI is also one of the tools, but it is a proprietary and very costly. Around 4-5 lakh rupees per systems license is required.
Mm-hmm. Okay.
Anyone else?
No, sir. There is an end of this no more question from participant side. So, sir, thank you so much. You have nicely explained each and everything, even the question answer also, and briefly teach us about everything. Thank you so much for educating us, and it will surely helpful in our future. So thank you so much, sir. Thank you.
Thank you very much.
Yes,
I
sir.
just try my level best in the field of the agriculture, which
Yeah.
is really helpful for all the students.
Students, yes, sir. Yeah. Thank you so much.
Thank you.
There is one request to all our participants that our next technical session will be start at 2 p.m. So please be on time. Thank you.
Okay.
Yeah.
Thank you.
Thank you, sir. Yeah.
Thank you.
Thank you.